All right, today we're jumping into a massive global cybersecurity upgrade. Seriously, it's one of the biggest happening right now. We're talking about the race to make our entire digital world safe from the computers of the future. It's called post-quantum cryptography, and it's not science fiction. It's happening as we speak.
So let me ask you a question. Do you think your data is safe? Right now, you trust encryption to protect pretty much everything, your emails, your bank account, your private messages. But what happens when the digital locks we rely on every single day could be shattered by the computers of tomorrow? This is the exact challenge the world's top cryptographers are racing to solve. The immediate threat has a name that sounds like it's straight out of a spy movie. Harvest now, decrypt later. And honestly, the strategy is as simple as it is terrifying. Right now, adversaries are just siphoning up enormous amounts of encrypted data. We're talking government secrets, corporate intel, your personal info, and they're just storing it. They're stockpiling it, basically betting that in a few years, they'll have a quantum computer powerful enough to unlock it all. This is the ticking time bomb that has companies like Google and entire governments scrambling to build their defenses.
Okay, so let's really get into this. To understand the solution, you first have to appreciate the sheer scale of the threat. We need to talk about why our current digital locks are so incredibly vulnerable. The difference in power we're talking about is just staggering. Today's public key encryption, it relies on math problems that are so difficult that a normal computer would have to guess for billions of years to solve them. But a powerful quantum computer, it doesn't just guess faster. It uses this incredibly clever shortcut, an algorithm called Shor's algorithm, to find the answer in maybe minutes or even seconds. It doesn't just play the game better. It completely changes the rules. And you don't have to take my word for it. Scott Crowder from IBM put it very bluntly. He said asymmetric cryptography is toast. And what he's talking about there is the very backbone of our digital world, the system of public and private keys that protects everything. Your online banking, secure communications, government secrets, all of it. That foundation of digital trust is what's at risk on Q-Day, the day quantum computers get that powerful. So, if all the old locks are about to break, what are we going to replace them with? Well, that brings us to the solution. Post-quantum cryptography, or PQC for short. Now, this is a really crucial point. Post-quantum cryptography isn't about using quantum computers for encryption. It's actually the opposite. It's all about designing totally new mathematical problems that are incredibly hard for both our current computers and those future quantum computers to solve. We're literally building a new generation of digital locks from the ground up, designed to be quantum-proof. So how are they doing it? Well, researchers are exploring a bunch of different paths to create these new quantum-resistant algorithms. You can see the main families here. From lattice-based to isogeny-based, you can think of these as totally different blueprints for creating an unpickable lock. The idea is that nobody wants to put all their eggs in one basket. By developing multiple options, the cybersecurity community is building this diverse toolkit. That way, if a flaw is found in one approach, there are others ready to step in. But, upgrading the entire world's security isn't as simple as just swapping out a bit of code. This new quantum resistance, it comes with some pretty serious engineering challenges and trade-offs we have to deal with. And one of the biggest trade-offs is just size. Look at this. An old standard key might be a tiny 32 bytes, but a new PQC standard, like one of the big winners from the recent standardization contest, might need a public key that's over 40 times larger. And that massive increase in size creates headaches for everything from the chips in our phones to all the data flying across the internet. But let me be clear, this whole transition is way past the theoretical stage. In 2024, the U.S. National Institute of Standards and Technology, you'll hear them called NIST, they finalized their very first set of PQC standards after this huge multi-year global competition. And the winners, with these awesome names like Crystals Kyber and Crystals Dilithium, are now the official gold standard for everyone to start using. And that brings us to the global race to actually get these new defenses in place. This isn't just a few academics tinkering in a lab somewhere. No, this is a massive coordinated effort by tech giants and governments to upgrade our entire digital infrastructure. You can see the momentum has been building for years. Google was already testing PQC way back in 2016. By 2023, IBM was rolling out toolkits to help companies make the switch. But 2024, that has been the pivotal year. You had NIST finalizing the official standards, and then right after, Apple announces this groundbreaking PQC protocol for iMessage. The quantum-safe future is definitely arriving faster than you might think. So,
I know this all sounds very high level. NIST standards, new algorithms, but how does any of this actually affect you? Well, the cool part is this super advanced security is already making its way into the technology you use every single day. A really clever strategy that's being used is called hybrid encryption. It's a fantastic belt and suspenders kind of approach. So instead of just flipping a switch to some new, totally unproven algorithm, tech companies are combining it with a trusted classical one we know works. That way, if a flaw is found in the new PQC algorithm, which, by the way, actually happened to a candidate called Psych back in 2022, your data is still protected by the old reliable encryption. It's like having a safety net for the entire transition. And Apple's new PQ3 protocol for iMessage, it takes this even further. It doesn't just use a quantum-safe key to start your chat. It continuously changes the locks as you talk. This ongoing rekeying means that every single message gets protected by a fresh layer of post-quantum security. Apple claims this makes it the strongest messaging protocol out there, and it's setting a whole new bar for the security we should expect from our everyday communications.
So, the digital world is successfully building its defenses against the quantum threat. And make no mistake, this transition is one of the most important security upgrades in the history of the internet. But it also reminds us that cybersecurity is a relentless, never-ending arms race. Which leaves us with one final thought. As we solve this monumental challenge, what new threats are already waiting just over the horizon? Thanks for watching.